So we'll discuss about next problem, that is find minimum in rotated sorted array. So this problem is the problem statement is that suppose an array of length n sorted in ascending order is rotated between 1 and n times. For example, the array num says 1 to 7. This is the actually original array. If you see this array 4, 5, 6, 7, 0, 1, 2, this is actually 4 times rotated, and second one is actually rotated. If it was rotated 7 times, again it will get the original thing. Okay, so notice that rotating an array a of 0, 1 to n one time, the result is a of n minus 1 and remaining numbers as it is. Given the sorted array nums, rotated array nums of unique elements, return the minimum elements of this array, and you must write the algorithm in O of log n time complexity. Okay, so they have given nums 3, 4, 5, 1, 2, and the minimum number is 1. And similarly for other example 4, 5, 6, 7, 0, 1, 2, so minimum number is 0, right? And other one 11, 13, 15, 17, 11 is the minimum number. So for this solution, what we will do is we will try to use the, as usual, we'll talk about brute force. After that we will talk about the other algorithm whatever suggested by the problem itself, that is uh, brute force one. Okay, that is the of log and time complexity one. Okay, given array 3, 4, 5, 1 and 2, right? These are the numbers we have. So first thing is we will go ahead with brute force actually. Brute force approach. Okay, so brute force approach, what we will do is we'll start from the index I with this number, and minimum number will, for example, I equal to 0, and minimum value also will initialize with the first number only, that is 3. When I is moving, I is 1 at position 1, it is 4, 4 and 3, compare what is the minimum value, we have 3. So here again minimum value will be 3 only. Keep moving, I equal to next value, that is 2. At this position 5, compare 5 and 3, and again minimum will be 3. And keep moving, now I equal to 3, that is equal to 1. Compare the value of I and 3, that now minimum value will change to 1. Now again move the index I equal to 4. Now compare that I and the value, whatever minimum value we have, that is 1 and 2, again minimum value will be 1, right? So through the brute force we'll get the minimum value 1, that is what we're expecting. And second solution, and this solution will be big O of n. Okay, this because we're iterating entire array one time. And second way of optimized solution is actually we can use divide and conquer method. Okay, divide and conquer method, so that we can just find the mid element and see this mid value and the left value and right value, whatever value you see that, compare these two values and keep change the mid and right and left values. Okay, fine, let's see now. Okay, uh, so how we can do that, this will be initially what we can do is we will try to uh, initialize the left value will be 0 and the right will be that is actually right index, right will be like a n minus 1, means length of the length minus 1, 1 2 3 4 5, that means 4. Okay, so what we need to check is we need to iterate through these numbers when L is less than right. Okay. Till this time we need to iterate this particular array. Inside this iteration, what we need to do, we need to calculate a mid term, mid value, that will be L plus R minus L by 2. Okay. Let us see now. We'll apply this. L is 0 and R is greater, so we'll come inside at the first time. In this case, M will become, what is L now? 0 plus, what is R here? 4 minus 0 by 2, that is equal to 2. That is a mid will become 2, right? Just compare if nums of mid is less than nums of right. If this is true, but in our case, mid of nums of mid, that is what? Nums of 2. Nums of 2 is 5, is less than nums of r. Nums of r is actually 2. R is now 4, right? This is 2. This is false, right? So it will go to if this is the case, what we need to do, we will move to the r equal to mid. Okay, that whatever mid value we calculated. Otherwise, what we can do is, and left is equal to mid plus 1. Okay, in this case, what happened? In this case, this condition is fails, so it will come here, and now left will become mid plus 1. What is mid here? 2. 2 plus 1, 3, right? So mid will become, left will become 3, and right remains same, that is 4. Okay, now left is 3, right? Left is 3, nothing but 1. In again, in the next iteration, L is less than 4, this condition is satisfied, right? Perfect. Now come inside. Now if you check it out, you calculate the mid now again. Now mid is 3 plus of 4 minus 3 divided by 2, that is 1 by 2, right? That means 3 plus some point 5 will come. So this is not, this is integer, so it will be, mid will be 3 only now. Correct. If mid is 3, now what happens if nums of 3 is greater than nums of r? That is correct. 1 is less than 2. So now right will become 3. Right also will become 3 now. Right? Again it will iterate. Now it will check L and L is less than R. No, because L and R are both are same. Both are same. So it will break that loop. It will come out. Now what we will do? We will returning nums of L or right, anything. What is L value? L is 3 now, right? Mid is equal to 3. Now L is 3. So what is 3 value? That is 1. This is the minimum value in the array. This how many iterations we took? Just log n actually. Okay. Okay, this is the theoretical part on understanding the logic, and this time complexity of this solution is big O of log n. Okay. Let's move for the implementation. Let us implement the starting thing is a brute force approach. Okay. Brute force approach, as we discussed, minimum equal to nums of 0. Initially, we'll initialize with that. After that, for we'll start from 1 till length of nums I plus plus. Just check it out that if nums of I is less than minimum, just initialize minimum equal to nums of I. Okay, but this is not the solution they're expecting. This is not the solution what actually they were expecting. We are expecting O of n solution, but this will pass all our test cases, whatever the best test cases we have, right? All passing. But what we will do is we'll try to implement the optimizer solution, that is log n time complexity one. For that, what we can do, as we mentioned, left and right will initialize with 0 and length of nums minus 1. We'll just try to see for left is less than r. Till that time we need to iterate this. Okay, we need to calculate mid, that equal to L plus R minus L divided by 2. We need to check that if nums of mid is less than nums of right, then right equal to mid, else left equal to mid plus 1. Once we are done with this, we just return nums of left or right, anything is fine. Okay, that's it. Let us run this. All tests passing, we'll submit this. This will be accepted, right? Okay, this solution basically will take big O of log n time complexity, and this solution basically takes big O of n time complexity. I think that's it. This is the, I think this is seventh problem from out of 50 DSA problems in Golang.